Right, this morning we're going to be talking about manual transmissions, and like it says there on the screen, the purpose of a manual transmission is to provide a variety of gear ratios for maintaining engine operation in the power band. So what we mean by this is our power band is a range of RPM. A lot of cars go from like 2,300 to up to 4,000. In other words, where they start making power to where they finish making power. And so what we do is our gear ratios allow us to keep the engine in the power band so the engine's making power while we're accelerating the car, going faster and faster in terms of vehicle speed. Okay, so we have several different types of transmissions. We have an rear-wheel drive transmission. This is one here. This is Tremec 5-speed rear-wheel drive transmission. And we have front-wheel drive manual transaxles that you see here in the picture here. This would be, of course, a longitudinal engine. This would be your transverse mounted engine. We can have 3-speed with or without overdrive. We can have 4-speed with or without overdrive. We can have 5-speed and 6-speed. And we have 8-speed manual transmissions now. We're getting more and more transmissions as we find that we need to get better and better gas mileage. In that power band, that range of RPM, there is one spot in there which we call, it's an RPM where the engine makes what we call peak torque. And at that point, the engine is most volumetrically efficient, meaning it's filling the cylinder at 100% or nearly 100%. If it's got a turbocharger or supercharger, it's going to fill that cylinder at over 100%. Volumetric efficiency refers to the amount of air that we can fill that cylinder. And that's where peak torque occurs, and that's where the engine runs most efficiently. And when we say that, that means it gets the best gas mileage making that quantity of power. Please understand that many cars cruising down the freeway at 70 miles an hour do not need all that power to maintain that speed. And so we have cylinder deactivation where we kill cylinders, etc. And but in any case, in terms of the amount of power we get out of an engine for the amount of fuel we put in, the best place to run it is that peak torque, most volumetrically efficient our engine RPM. Let's continue. So major components of a manual transmission are the case and the extension housing. This is the case here. This is an extension housing. This is what we call a top loader transmission with a top plate there. We've got an input shaft or clutch shaft, which is the shaft that's splined to the disc to bring engine power into the transmission. And then we have a main shaft or an output shaft that takes power out to the drive shaft. I've got a transmission right here on the bench. I'm going to go ahead and take the camera over there and we'll take a look at it. So we'll get pause for 1 sec. So what you have here on this 5-speed Toyota manual transmission is this is the input shaft where it splines to the disc, and the input shaft goes in and stops right about here. From this point on, all the way back to the back is the main shaft. There's the end of the main shaft that's splined there to the slip yoke for the drive shaft. So the input shaft stops here, and the main shaft starts here and goes all the way out. The next one coming up is called the counter shaft or cluster gear. So every manual transmission that's rear-wheel drive is essentially 3 shafts: input, output, and counter shaft or cluster gear. So if you come on back over here, that should come up next here on the screen. Let me just go ahead and readjust myself here. Okay. Okay. So next is our, hang on 1 sec here. So next is our counter shaft or cluster gear, like I mentioned, which allows for different gear ratios. So if you look at this picture, you'd have your input shaft coming in over here, your output shaft going all the way out, and your counter shaft or cluster gear. And if you're looking at this picture and saying, Mr. L, how do you know that that was the input shaft and this is the output shaft? That's the speedometer drive gear that's always on the output shaft. That's how I knew. Okay, next. So we also have a reverse idler gear that reverses output shaft direction. And so I can grab this case half over here. So in this case half, this is the reverse idler gear here, right there. And that's used, it's a separate little shaft with a gear that's used to reverse the direction of rotation of the output shaft so we can get reverse. Let's keep going. So then we've got shifter forks to move our synchronizer assemblies, and our synchronizer assemblies, which allow for gear shifting. And then we've got bearings, input shaft bearings, output shaft bearings, and counter shaft bearings. So let me grab the camera again and walk over, and I'll show you our shifter forks and our synchronizer assemblies and where our bearings are. So again, hopefully I don't make you seasick. Taking the camera over here. Here's that same Toyota 5-speed manual tranny. Okay, so what you're looking at is one shifter fork here, another shifter fork here, and another shifter fork here. Down in here you can see 3 shift shafts, 1, 2, and then the third one over here. And the shifter comes down out of the top of the extension housing there, it's off, and moves these 3 shift rails back and forth to move these shift forks to shift the transmission. So this one is first and second shift fork and synchronizer assembly right here. First gear is here, second gear is here. This is third, shifts over here, fourth shifts over here. Okay, third here, fourth here. Fifth gear is back here, and reverse is right here. And I'll go through shifting those so you can see those in a few minutes, but not right at this moment. Let me come back over here, put my camera back up. Okay, there we go. Okay, so let's continue here. So service procedures. I'm going to pause here and let's take the time to show you how the shifters and the forks and things shift. One sec. All right, so here we go. I'm going to show you with my plastic mallet how we're going to shift through all the gears. Hopefully what you can see, and yeah, looking at the camera, you can see. So you can see the brass synchronizer here, and you can see one there, 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 and one over there. I'm going to bring the camera in real close. Reverse is not synchronized. So there's a brass synchro ring right there, this guy here. There's one back here. There's one there. There's one back here. And there's one back here on fifth gear. Notice there's no synchronizer brass ring on reverse, okay? It does have synchronizer teeth on the gear that match the synchronizer sleeve. All right, so let's go put the camera back up here. Hopefully you can see what I'm doing here as I shift through the gears and get that thing to focus. Focus, dude. There it goes. Okay, so what I'm going to do now is show you how we shift through the gears. So remember, this is the input shaft here. So power is coming in from the engine with a clutch disc splined to this. So first gear goes like this. We're going to knock the first gear shifter over there. And when that shifter fork moves this synchronizer hub sleeve and it grabs onto those teeth, it's going to grab this gear. So power is going to come in like this, go in through this hub sleeve, grab through this gear, and it's going to go into the main shaft. Sorry, it goes into this gear, through the counter shaft, and then back here and out the main shaft. So the power flow goes like this, 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 this. Because this gear is meshed with the counter shaft 100% of the time. And now what I've done is I've locked this gear to the main shaft. So now power is coming in. Sorry, I did that wrong. Let's back up. I just made a mistake. Power comes in the input shaft, goes here into the counter shaft, down to here, up into here, through the synchronizer and out. So one more time. Sorry, the first time I was wrong and delirious. In, down, here, here, into the synchronizer, out. Because the main shaft is, this gear is locked to the main shaft at this point. This is 100% meshed here all the time. So power flow is going to go down through here, and out. Okay, so after that little escapade, let's go back to neutral. There's neutral. Now we're going to get second gear. So this first, second gear is synchro, and if you think about it on your shifter, first, second are in the same gate. They're on the same shifter rail. So now we're going to go for second gear. There's second gear. So power comes in on the input shaft, down to the counter shaft, over to here, up to this one because it's locked to the main shaft there, and out. So like dun, 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 out. That's our power flow for second gear. So you may be wondering, so Mr. L, how is it that this hub sleeve is locking these gears to the main shaft? This hub sleeve is on a sliding synchronizer. Sorry, this sleeve is on a sliding synchronizer hub. The hub is locked to the main shaft. When this sleeve, which is grooved to the hub, grooves over these teeth on the gear, it locks this hub sleeve to that gear and to the hub itself. So this becomes locked to the main shaft. That's the best I can do without having here. Here comes third gear. So there's third gear there. So now we're coming in like power like this, down to the counter shaft, up over here, up to third gear, into the synchronizer and out. So it's like this. And then we'll go back to neutral. And now we're going to shift fourth gear. There's fourth gear there. Fourth gear is unique. Power does not go down through the counter shaft. Even though it's spinning, it's just going along for the ride. This locks the hub sleeve. The hub sleeve locks the hub, which you can see underneath there, to this gear, and power just goes straight through. So it's a one-to-one straight through on fourth gear. So first, second, and third are our forward reduction gears. Fourth gear is one-to-one. And then fifth gear back here, it goes like this. There's fifth gear. So now power is going in, going down here, going down here, going down here, and going out. And that's fifth gear. And because of the difference in size of gears back here, this is going to spin faster than the input shaft. So that's overdrive. Fifth gear is a 20% overdrive on this one, like this, like this, like this, and out. Finally, reverse. So there's neutral. Here comes, there's reverse right here. Now, in reverse, what happens? Power goes here, goes here, goes here, goes here to the reverse idler gear, and then to here. Because you notice these two gears are not actually touching. Let me get the camera down there, you can see these two gears are not actually touching right here. These two are here, that's first gear there, but these two in reverse are not actually touching each other. It's this reverse idler gear that goes between them that reverses the direction of rotation of the output shaft. Okay? So there's our shifting of our manual transmission. I will show you one other thing here, how the synchronizers work. So the synchronizers work like this. We've got an input shaft. And when you look at this input shaft, this has cosmoline on it, which is like a lubricant, but this is actually tapered. The brass synchronizer rings are also tapered on the inside. This is not the right one for this, but these actually come together, and as they get pushed together by the hub sleeve, they match speeds and then they spin together. And once they spin together, the sleeve can slide over and lock onto these teeth. When you grind gears, what you're grinding is this hub sleeve right here hitting the front edge of these teeth on the brass synchronizer rings. These brass synchronizer rings are replaceable, a normal rebuilding part when you're rebuilding a manual transmission. All right, so let's continue talking about service procedures for a manual transmission. So we're going to change the fluid every 30,000 miles. And you can see on this gear set, it's pretty dirty, okay? But that's okay. You know, that's normal. You can see the brass synchronizer ring there. The hub sleeve is moved all the way over on this one, it's exposing that. By the way, when these wear, they wear that little triangle tip there off, and then they don't shift as well. We're going to change the fluid every 30K or every other year. Most manual transmissions use gear oil, which is 75/85. There are some Ford Rangers that use ATF. Older Honda front-wheel drive transaxles use 30-weight oil, and some use synthetic gear oil. When we rebuild, we're going to replace the synchronizer rings, or they're also known as blocker rings, these guys here. So all those synchronizer rings and blocker rings automatically get replaced. They're a wearable part. We're going to replace all the bearings. So the input shaft bearing, the output shaft bearing, the two counter shaft bearings. There's a bunch of small parts. There's some keyways, there's some roller bearings where the output shaft fits into the input shaft. There's a bunch of roller bearings in there. So there's a bunch of small parts and gaskets as well. There's some seals and some gaskets. So those are the parts that we're going to replace when we rebuild the manual transmission. Hopefully we don't have to replace any full synchronizer assemblies, but the forks that go in the hub sleeves here, sometimes it wears the hub sleeves out and sometimes it wears the forks out, and then they have to be replaced when they have too much wear. Otherwise, when you shift, it may not go all the way into gear and may pop out of gear and things like that. So we will pop out of gear when we have worn shifter forks and hub sleeves and bad motor mount or tranny mount as well. We're always going to replace the clutch at the same time when we rebuild the manual transmission. A little bit about problem diagnosis. So first, noises. So bearings, the input shaft, remember we say if it's making noise, it'll make noise until you depress the clutch and then it goes quiet. The counter shaft will make bearing noise in all forward reduction gears, but not in direct drive fourth gear. So that's a way we can diagnose those bearings. The output shaft bearing would make noise all the time except when the car is not moving. We can identify these by tests in motion, in gear or neutral, stop, clutch in, clutch out. So when somebody says my transmission is making noise, they say, okay, is the clutch in, is the clutch out, is the car rolling, or what's gear are you in, et cetera, et cetera. So we can kind of identify. When power is going through a bearing, that's when it makes noise. When no power is going through a bearing, it doesn't make noise. If it's just freewheeling, it doesn't have any power going through it, it probably will not make any noise. Gear whining. We will get a gear whine, which sometimes when the gears maybe have a burr on it or got chipped, you can get a gear whine. It's not very common from my experience. Hard shifting or won't shift is another category of problems. So a worn or improper clutch adjustment is the first thing we look at when we are having trouble shifting. Think clutch. It's like 99% of the time, it's either a worn clutch or a misadjusted clutch. A worn or misadjusted shifter, like I was saying, or no, I wasn't saying, but if the shifter mechanism itself is worn or misadjusted, it may not push in all the way or might have hard shifting, etc. Improper fluid level or type can make a difference. Improper fluid level or type can cause hard shifting or make it so it doesn't want to shift right. A bad engine or transmission mounts. So when mounts are bad, the transmission may not want to stay in gear, it may want to fall out of gear, it may, etc. I've seen people move their console. See if I have that on here. No, I don't. I've seen people take their console out to put a stereo in, whatever. They don't get it back in right, and it keeps knocking the gear shift out of gear. Worn synchronizer rings, those brass synchronizer or blocker rings, that will make it so it doesn't want to shift properly. It'll grind, it's hard going into gear, etc. And then a worn shift fork, like I said, where it fits into that hub sleeve, the synchronizer hub sleeve. If they're worn, then it's not going to want to push all the way into gear, and it may want to pop out of gear, or maybe hard pushing into gear. Okay, if it falls out of gear, kind of what we've already said, motor or tranny mounts might be broken. A worn shifter fork, if the fork's worn, it might not push it all the way into engage in the gear, and it may fall out. And a worn shifter mechanism. So when you're trying to shift, it's not pushing something all the way into gear and it wants to fall out of gear. And that's it. Awesome.